Okay, what I'm going to do, I hope this works. I'm going to share my screen to, I hope I'm sharing the right screen. Okay, so what I have in front of us is both my Setonix and a Linux shell on my PC. And what I'm going to do is I've got clear. I can't even ls. As you can see, both of these have the same files. Both of these are Git repositories, right? So they're both initialized to the same repository. They both have the same information in them. Now, what I want to show you is, and I'll ask you to work along with the notes in the Git manual as I show you this. So let's say you've got Git on your PC or your Mac, and you've initialized a repository. It's all good, but you want to work on another computer like Setonix, for example, or vice versa. So you'll have to go through the same process again of setting up those SSH keys and adding that key to your GitHub account, right? So we've seen this in the previous section, how to do that. I've done that both on my Setonix and on my PC. Okay, the next thing I've done is I've actually cloned the repository into my PC. And let's say I want to make some changes to, or I want to add a file. So let's go nano dogs.txt. And I'm just going to say dogs are amazing. I'm going to save that. Now I've got dogs.txt. So what I'm going to do now is I'm going to go git push origin main. Origin main. And what that should do, oh, actually, I haven't git. I have done something wrong. And I hope you figured out what I've done wrong, which is I didn't add, if I go git status, I haven't actually added dogs.txt to my staging area. So I have to do that first. Git add dogs.txt. And now I can do git commit and add a comment message, and that's going to be adding a file about dogs. Oh, I haven't done that. Sorry. I just set this up 5 seconds ago. And now I should be able to do that. Okay. So now that I've done that, I can go git push origin main, and that should push the changes I made to my remote depository. So if I bring over this window, you can see that now I've added dogs.txt. Okay. So let's go now onto Setonix, and if I type ls, I don't see dogs.txt, do I? I only see mars.txt. Why is that? Because I haven't actually pulled those changes from the main branch. So in order to do that, I would go git pull origin main. And now, after that's done, it's fetched those changes from the repo. You can see that I've got dogs.txt. Great. So that's essentially the concept here. You can have Git working in several locations. You can have your friends working on the same repo. You can make changes. You can pull the changes from the repo. You can push the changes to the repo just like that. Does that make sense? Okay. So what I'm going to do next, and I will come back to some of the stuff in the Git manual in a moment, but we're going to just skip ahead to chapter 9, and I'm going to show you, let's say on my PC, I wanted to make a change. Let's go dogs. Border collies are my favorite dog. Okay, so I've just made that change to my dogs.txt file. Right, you can see that I've made that change. And I'm going to, again, git status. You can see that I've modified that. So I'm going to go git add dogs.txt. And then I'm going to add git commit -m and add a comment message, which are information about my favorite dog. Okay, now that I've done that, I'm going to push that to the repo. Again, if I look into my repo, I'm just refreshing, you can see that now that comment message appears and it's updated appropriately. But now I'm going to go into my Git on Setonix, and I'm going to go and edit dogs.txt. And I'm going to say woof woof. Okay. So I've made that change to dogs.txt. Let's say git add dogs.txt. So we'll add that to our staging area. And then I'm going to add a comment message, which is information about dog noises. Great. So I've just made a change to dogs.txt on Setonix. I've added that to the staging area. I've created a new comment. Now, what I'm going to do next is try to do the exact same thing. I'm going to try to push that to the repo. Git push origin main. What is going to happen? Error, failed to push some refs to github.com, blah, blah, blah. Updates were rejected because the remote contains work that you do not have locally. This is usually caused by another repository pushing to the same ref. You may, blah, blah, blah. Okay, so it gives me an error message. And this is a conflict. I have made some changes to dogs.txt on my PC, and I pushed that to the repo. Then I've made some different changes to dogs.txt on Setonix, and I've tried to push that to the repo. And now there's a conflict because those two changes are essentially incompatible. Okay, so what can I do? Well, the first thing I can do is I'm going to pull in Setonix. I'm going to get the most recent changes. So git pull origin main. Okay. And it's telling me that I have divergent branches. So if I go git status, this is nothing to commit. Now, if I go into cat dogs.txt, you can see that it hasn't made any changes. And that is because I need to do git config pull.rebase. Yeah, so I'm just going to tell Git how to handle situations like this. Okay. And this will allow it to merge those changes. Okay. So now if I go git pull origin main, it's trying to merge those changes, and it's not working. So if I go to git status, again, you can see now I've got unmerged path that's telling me. If I go cat dogs.txt, what it's done is it's saying that on my head, I have dogs are amazing. You know, border collies are my favorite dog, but it hasn't been able to merge those appropriately. Okay. So our change is preceded by head. And then what Git has done here is it's added these equal signs as a separator between the two conflicting lines. Okay. So this conflict, Git is not sure how to resolve. Okay. So this precedes the change. So head is up to here. That's fine. Then anything afterwards is a conflict. And this is the two lines that are in conflict. Okay. So now what are we going to do? We have to go in and edit the file to resolve the changes ourselves. So if we go nano dogs.txt, we can decide what we want to do. We want to keep both of them, or we want to delete both of them, or we want to keep one or the other. I'm going to decide to keep both. Right? Now, if I do git status, oh, actually, I have to add that first. And now the conflicts, it's telling me the conflicts are fixed, but I still need merging. Okay, so now after I've gone in and I've edited out what I think has been the problem, I've fixed those conflicts. Now I can do git commit -m fixing conflict. Okay, great. Now I can git push origin main. We go into the repo here. You can see that the message has updated appropriately, and I have both of my lines in there. Okay, so that is what a conflict will look like. And again, just the steps to that are you will have to pull from the origin, and then you will have to then go into the file and resolve that conflict manually. Okay. So if I were to go into my PC and do git pull origin main, you can see now those changes are appropriately merged. Okay. So that is essentially what a conflict looks like and how to go about resolving it. Now, you will hopefully notice that let me just see if I can find. Okay. No, I'm just gonna, give me one moment. Okay, so now that we've done that, I think that's given you enough background as to how that operates. What I'm going to do is go back into, where have I put the Zoom thing? Sorry, folks, I just need to find where I put the Zoom controls, which have gone missing. Here they are. What I'm going to do now is go back into the manual, and we'll just work through a couple more things. Okay. Hopefully you can see the appropriate screen now. So this basically describes what we've just looked at first in terms of like, collaborating if you want to use Git on multiple devices, or maybe your friend wants to work on the same repository that you do. There are some little caveats here. So one is that if you're working with large data file, that can become problematic. So if you've got large data folders, if you've got, for example, big analysis files, you might want to add them to your .git ignore before you stage the commits. But also, there is a way to get Git to handle those, which we'll look at in a moment. What if you want to share your work with other folks? Basically, it's the same concept that I've just showed you. You've got two people working on Git through the command line on two different machines. It's just that there's two different people working at each machine. So what you do is you go into your settings in GitHub, you go on to manage access, right? And you're going to have to invite someone to be a collaborator, okay? The collaborator can make those changes, all right? But you will need to grant that access first. Okay, so if I go into my Git settings, I have lost where I am. It's my repository settings, not in my settings here in the repository itself, not in your account settings. And then you go collaborators. I've set this up as a private repository, but I can add people, right? So if they have a GitHub username, or they have an email, you can just send an invitation to them to help collaborate on your repository, and then they can do the exact same thing. They can access the repository, they can make changes, they can push and pull commits. Okay. Now, for a public repository, anyone can pull from a public repository, but unless you're a collaborator, you won't be able to push changes to that same repository. So you can actually clone it and then set up your own repository based on what's publicly available, but you won't be able to amend or change that repository yourself. Okay, does that make sense? And unless you're a collaborator. So you have to invite people to be a collaborator for them to be able to make changes in your repository. Okay. Wait, is there anything else on this page? No, it's basically the same thing. We're talking here about remotes. A remote is basically a copy of the repository that is hosted somewhere else. In this case, I have the repository on Setonix and on my PC, but the repository is actually hosted here on GitHub. All right. So I've called that remote. So I've just seen it. Aren't private repos paid? Do we get private repos as interns? Okay. So let's say I wanted to go into my repositories and I wanted to make a new repository. I can actually set it to private here, and that's just an easy option choice. Okay. So you can choose who sees or who has access to your repository. Okay. That's just the answer to that. You don't, they aren't paid. Okay, so yes, like I said, a remote is a copy of the repository hosted somewhere. And we've decided to call the repository here, we've called this copy origin. Okay, but it can actually be called anything. So for example, here, you can have the one in your own GitHub account origin, but maybe you have an upstream repository that is somewhere else where the same project basically is working on. You can pull from that at any time. You can have multiple remotes at the same time, and you can pull and push to all of them if you want. And the alias that you choose for that, it can be anything you want. You can be origin, upstream. Typically, they have defined meanings, but you can call it Fred, as it suggests here. So here are a couple of options that you can work with. You've got Git remote, -v that will list all the remotes that you've configured. You can add a remote, give it a name of your choosing, and then the URL, the link to that remote. You can remove particular remotes. If you have added a remote, but then the URL has changed, for example, if it's moved to a different location or a different hosting service, then you can just change the URL. And you can actually rename the name. So if you called your remote Fred and you want to call it something like cow, you can actually just do that with Git remote rename. Okay, so you can handle your remotes like this. So this is how it should work. When you begin working, the first thing you should do is pull origin main. So you get all the changes from the from origin. Okay. That means that your local copy then is up to date. You can then make your changes and then you stage them with git add, which is easy, very easy to forget, and you've seen me do it in front of you. You can then commit your changes with git commit -m and add your commit message, and then you can upload your changes to the remote repository with git push origin main. Okay, so these are some handy things you can do. So let's say you've made some changes while you've been working, but you don't necessarily want to push them, but you just want to have them, you kind of want to like save a snapshot of the changes you've made, but then like you actually want to go back to the main kind of, you want to go to the current commit, right? So you've made the changes, but you want the files in your directory to be the same as they are on the most recent commit, but you don't want to lose the changes you've made. You can actually stash them away, and you can do that with git stash. That pushes the changes you've made somewhere, and you can actually retrieve them at a later date. But it will change all the files in your local directory to what they were before, but it will preserve the changes for you to retrieve at a later time. You can update your branch with git pull. Now, if you have stashed some changes, you can bring them back with git stash apply and merge those with your most recent code. Git add, and then the file name to add your changes, or in this case, a dot will add everything. Git commit with the message will commit your changes, and git push will push your changes. Okay, so those are the commands that you're going to encounter and use most often as you're working with Git. Going into conflicts now. So we've gone through this already. I've shown you what that looks like. So just once again to reaffirm the best way to work in Git, you have to, especially if you're working with other people on the same repository, you want to be pulling from your upstream repo more frequently, especially if you log onto your computer, you begin to start work. It's a good idea to pull, right? As soon as you start working. So if anyone's made changes overnight, for example, you can just have those changes in front of you. You can use branches to divide the work up, and then you can merge those branches to the main branch when you're done. So here we've got, we've had git push origin main. Origin is a remote, main is a branch. So you can actually fork that branch and make a new branch to divide the work. It's a good idea to have your commits be defined. So make commits that relate to specific things. What's here described as atomic. So you've changed one thing, you commit it. Then you make another change, you commit it. All right. As opposed to like changing all of the code all at once and then committing it. That makes it maybe potentially harder to resolve conflicts. Okay. And here it says, where logically appropriate, break large files into smaller ones so that it is less likely two authors will alter the same file simultaneously. So if you can, it's good practice to have different people working on different parts of your project. That kind of helps to avoid those conflicts. Sometimes that is not possible, but where it can work, that's good practice as well. So here it's suggesting some ways to minimize conflict. So clarifying who is responsible for what with your collaborators, so you know what you're working on to avoid conflicts. Discussing what order things should be done. Okay, so you won't have the same lines of code being edited at the same time. And then if the conflicts are stylistic churn, I have a very defined stylistic preference when I write code that may not be the same as yours. So you may want to talk about what are the standards for the project where you're working on. And you can also use some code styling tools to help you do that as well. And they've given you some examples: HTML tidy, Perl tidy, Rubocop. Okay, but there are plenty of others. Okay, so let's look at let's talk about what if there's a conflict on a non-text file. Okay, so let's suppose Dracula from earlier takes a picture of the Martian surface and calls it mars.jpg. Oh, yes. Sorry, Thomas.
Yeah, I didn't want to interrupt you, but you're moving on, so I thought I'd just say something now.
Yeah.
When you talk about git pull, like when you say I might make like put that in the bash RC file to just like when I set up, when I start for the day, I just do a git pull. But like, say like my project's on molecular modeling. Say someone's say we've got like a GitHub account, and I've pulled some, like, say somebody's changed something about one of the libraries I'm using or something, and now the simulations I was previously running on that version, like if they've made a change, it could break it or something. So when you do a git pull, do you always go to like, how do you manage like the programs you've been running in previous versions of the GitHub repository?
Right. Yeah. So that's a really good question. And that's one of the things that Git is really useful for, because you have that control over versioning, and you can actually go back at any stage to a previous sort of commit. So if something has been broken or something's not working the same way, you can actually like go back, right? And that's one of the handy things you can do with something like Git checkout. You can actually revert some changes. So at every stage, if you're, even as you're pushing and pulling, let me see if I can. One second. I forgot how to do this. No. I will have to show you that later because I forget where things live here. But basically, you'll be able to, Git will track the changes, and you can obviously pull from the main branch in the most recent copy on the main branch, but you can also go back steps. So you have control over versioning, and you also have control about what you're actually working on at any given time. If a change has been made that is becoming a conflict for you for some reason, this is also why you're able to create a fork And it's also why you can have multiple remotes. So you can have a remote that is sort of connected to the main project, but you can also have a remote that's connected to your own sort of repository. So you can actually work on two places at once. So you're not confined to just one repo for any given project, and you can branch out. Does that help clarify things a little bit?
I think so. I guess like the question I had is, it's like some of these data files are going to end up being quite large and probably too large for you to, like, I think, put on GitHub. So in that case, would you just have some kind of like, I don't know, like a README file or something telling the dependencies of the GitHub version you use when to process that data? Because if you tried to do it again, you got different results.
Yeah, I think that is good practice. What I will do is part of what I'm going to show you a little later on is how to deal with those large files, but also if you're working on code, and code versioning code is really important. You do have, and I wish I could find where these things live. Where? History. Okay, you see how you've got all these commit IDs?
Yep.
You can actually refer to those particular versions with these commit IDs. So like on that particular commit ID, this is how I ran that analysis, right? So this is also quite helpful for you to keep a note of. And I would actually have a metadata or README file or some kind of description of your work that makes reference to these versioning identifiers. That is best practice.
Okay, thank you.
Yeah, no worries at all. Okay, so just going back here, if we have a conflict on a non-text file, so we have an image, for example, so we've got this image mars.jpg. So now let's add mars.jpg to our repo, and let's say that someone else has a mars.jpg, but it's a different mars.jpg. It's a completely different image. And they also want to push that to their repo, the same repo. That's going to obviously be a conflict, right? And we know that to avoid those conflicts, we probably want to begin with pulling things first. But when the conflict is on an image file or any other file that is non-text, like a binary file, we get a bit of a message like this, which is basically the same as what we saw previously, except for this line. Cannot merge binary files. So what we saw with the text files is that Git will attempt to merge them, and it will give us those little indicators as to like what the conflicts were within the text file. So we can go in and resolve them ourselves. It cannot do those with binary files, however. What we can do, though, is we can decide what version of the file we want to keep. Okay? Git will give you identifiers. So in this case, we have this identifier. And the version that's currently on the repo is head. So if we want to use our version, we just check out head, right? You know what that does. That restores the image or the file from the most recent commit. And we can just commit that. But if we don't want to use that version, we want to use the other version, because we have the identifier here, we can actually check that out instead and then commit it. Okay. Now, there's another way to resolve this, which is you can actually keep both images. So if you check out head mars.jpg, and then what you can do is you can change the name of mars.jpg to something else, like Mars Surface, but then you can check out the other version using this identifier, and you can change the name of that to something like mars.sky.jpg. You then will remove this file, the mars.jpg, and you can add both Mars Surface and Mars Sky to your staging area and then commit it. So you're able to resolve the conflict by keeping one or the other or by keeping both. You will just need to change the names. And if you don't recall, mv is the move command. It allows you to move files to different locations, but it also allows you, and this is maybe not intuitive, it also allows you to rename things, which is another way of saying move this file to where it's already in, but with a different name, right? So that's what mv does here. It will rename mars.jpg to marsservice.jpg. Okay, so let's look at a typical work session. Let's say you wanted to do something like you had these tasks, right? What order should you perform these tasks in during a typical work session? So we've got make changes by appending the number 100 to a text file, update the remote repository to match the local repository, celebrate your success, update local repository to match the remote repository, stage the changes, commit the changes. What should come first? What do you guys think? Someone knows the answer to this. It's the first thing you should do when you start work. Yes, update your local repo to match the remote repo. Yep. So then the next thing we've done was we've made that change by appending the number 100 to our text file numbers.txt. What do we do after that? What's step 3? Git add. Yes, we stage the changes. Okay, what do we do after we stage the changes? We commit the changes. And then what do we do? Last thing. Git push. So we update the remote repository to match the local repository, and then we celebrate. Okay, so that is the workflow with Git. So that is chapter 9. Now, the last couple of chapters, would you need to make sure all your work from the previous day is committed before pulling? Yes. Presumably, if you have been working the previous day, you would have done Git push before closing down your session. But if you want to double check that you actually have done that, then you would just do Git status, and it would tell you if there are changes that need to be pushed, right? But again, bearing in mind that you don't want to push something if other people have already made other changes in the meanwhile, because then you generate those conflicts. So just be mindful of that. I think it is a good idea to make sure that you've committed and pushed all your stuff before you sort of leave